In the previous video, we talked about how we can find a rate of change from a table by looking at how each side of that table goes up. How do we do the same thing when we're given a graph to go by? So let's start off by looking at what this graph means. We'll start off with the one on the left. Can we find the rate of change? So if we look at what's on the axis says number of toppings is this axis, the x-axis, and cost is on the y-axis. So what basically this is saying, we can assume, I'm going to tell you right now, this is about sundaes, like an ice cream sundae. So pretend you're going to an ice cream sundae shop and you want to buy an ice cream sundae. And we want to find out how much it costs. We want to graph how much it costs to get a certain number of toppings. Each topping that you get, you can see the cost goes up, right? So this is the cost over here. So the cost goes up as we order more and more toppings, which makes sense. And you should also notice when we get 0 toppings, the cost is $6, right? If we go straight up from 0, we get to the graph at $6. So that means it costs $6 for no toppings, which makes sense because you have to pay for like the ice cream and the little cup itself, right, that you're going to get the sundae in. So it makes sense that there's some cost even if you don't get any toppings. It's like basically getting a plain ice cream. And then on top of that, you pay for each topping, right? So when we're asked to find the rate of change for this graph, or the rate of change for this graph, we're actually looking for the cost of each topping. How much does it cost for each topping we add on? Okay, that's the question we're asking. How do we do that? Well, I think by now we should be good at finding the rate of change from the table of values, like the last video. If you're not good at that, please do a little bit more practice with that because it's really going to help you out here. Because what we can do is we can just set up our own little table. And the table here, I'm just going to set up a little T table here. And this I'm going to call toppings. Oops, let me move that. I'm going to zoom in a little bit down here. So toppings and cost, or dollars. Those are the two things we're comparing with this graph, right? Toppings and cost. We want to know the cost per topping, right? So that's another way you know that these are the things we care about. Now, we can set up our own table. In the last questions, in the last video, we were given a table. Here we can set up our own table. So let's pick a few points from the graph. So first of all, we know if we get 0 toppings, we're going to pay $6. So let's put that in our table. 0 toppings cost $6, right? Now, in order to make this table work, we need another point or another few points on the table. Now I'm looking here and I could maybe go two toppings costs, I don't know, that's between 2 points. That's confusing, right? But if I go from $4, or 4 toppings I should say, it's going to take me right to the axis here, right to this point here. So I think this is a good point to choose. Okay, if we go right up from 4 toppings. So 4 toppings costs how much? Well, what is this value here on the graph? A little bit tricky here. We notice that $6 is here at the second line. So how much does each line represent on this graph? It should represent $3. So we have $0, we have $3, we have $6, we have $9, we have $12. If we keep on adding 3 each time. And we have $15, $18, $21, right? I'm just adding 3 each time to the graph to fill in those blanks. So now that we know that, how much does 4 toppings cost? Well, if we go right over from where those 4 toppings were, it costs $9. And we can keep going. The next easy one to pick is this point right here. We always want to pick points that fall like on the grid lines, like on the corner of the grid lines. This one's not as easy because it's between 2 grid lines. We want to find one that's on the grid line. So this point is a good one here, right? This one's a little bit confusing, but this one's good. So this is 8 toppings, because if we go straight up from 8, we get to the line. And if we go straight over, it gives us 12. So we go straight up from there. 8 toppings costs us $12. Do we have enough information here to find the cost per topping? Well, if you think about it, this is the same thing we did in the previous video, right? To find the cost per topping, or to find the unit cost, we need to find out how much it goes up by over here. And if you look at it, it's going up by 4. Oops, let me change to blue pen. It goes up by 4. And then it goes up by here by 4 again. I'll put a little plus there to see it's plus 4. I know we're squeezing it at the edge of the page here. And then what happens on the other side? So for each 4 toppings we add, how much more does it cost? Well, we go from 6 to 9, so that costs $3. We increase it by $3. And then from 9 to 12, we add another $3. So the cost per topping here, we got to divide the cost by the topping, because that's exactly what this means. It means divide cost by topping. So in order to do this, we know it's going to be $3 per 4 toppings. And if we divide that, $3 by 4 toppings, we get $0.75 per topping. So that's the answer, 75 cents per topping. Okay? And that's it. So each time we go up by 1 here, we actually add 75 cents. Okay? So, again, I want you to pause the video right here. Try the your turn question yourself. When you unpause it, I will reveal the solution to you. Okay? Pause it now. So there we go. There's my solution. 50 cents per topping, or $0.5 per topping. The way I did this was I made a table, right? And I looked at the ones that fall right on the corners of the points. So these 2 points and the starting point is a good one. This one starts at $12 for 0 toppings. At 6 toppings cost $15, and 12 toppings costs $18. So on this side of the table, when I recorded those values, on this side of the table it goes up by 6, on this side of the table it goes up by 3, and you get 50 cents. I'm going to give you a little secret here that might make your life a little bit easier when you're solving problems like this. Do we need to put all 3 of these points here? Well, I could have just done the same thing just with this 6 and this 3. I didn't actually need this point, this third point down here, and I still would have got the right answer, right? I'm just doing 3 divided by 6. So you actually don't need to put 3 points. If you want to do this, you only really need 2 points to do this. I always just put the third point as a way of checking to make sure I got the right answer. So it's a good idea to do it, but you don't need to do it when the graph is a straight line, okay? Because no matter if the graph is a straight line, no matter where you do this, you're always going to get the same answer, okay? So your task right now is to finish the rest of the problems on this handout, okay? So there's 6 more problems. The answers are down here at the bottom, okay? Give those a shot.